Highway engineering. I hope you have seen the previous sessions. This will be okay. I will give you a short introduction. So, if you remember, we are in under the course of transportation engineering. Under the transportation engineering, I think I have given a detailed discussion in the video session 1 about railway engineering, airport engineering, what we are going to see. So, we are in the session of highway engineering. In the previous session, I hope we have completed this history and survey. If you have any doubt, you can ask me. And we are now in the session of geometric design. So this session we are going to see introduction lectures about this geometric design. Okay. From the next session, if you can see, we will go by each geometric design, and then we will be solving problems at the end of the each session. Okay. So I hope you understood where are we now. This session we are going to see this one, introduction about the geometry. Okay. So I hope you should know first what is geometric design, because I've been keep on telling you, like, at least 40% of the scoring marks, everything coming from this geometric design chapter. So you should realize that how important this chapter is. Before that, theoretically, not based on a exam point of view, if you remember, if you see the term called geometric design, we are going to decide the geometry of the road. Okay. So I hope you have studied the geometry. We are going to define so many things, like we are going to in next coming slides I will tell you in detail. Anyhow, so we are going to design vertical curves which is about to come in the roads, something like this. If the vehicle is going like something like this, okay. So if you remember, so how to define this vertical curves, how to define this horizontal curves. Consider the vehicle is going something like this. So horizontal curves and vertical curves, something like this, and something like how to maintain the gradient, how to maintain the design speed, and what are the factors which is going to affect the vehicle dimension, user characteristics, everything we are going to see in detail. Okay. So this is called geometric design. We are going to design a geometry of your highway concerning about all the parameters. Okay, we are going to take consider of all the parameters. We are going to design the geometry. Remember, geometry doesn't means we are going to decide any thickness of the road. This is, if this is a ground level, we are not going inside the ground level, just we are going to define the geometry. Okay. So if you also, in other time, if I say, if you are looking at from the top view, just I am going to see some, if you see, look from a top view, consider the road is something like this. So this is what you are going to decide, like how the geometry of your road looks like. Okay. I hope it is clear what you are going to do in this overall chapter. For next at least 4-5 sessions will be coming under geometry design. This is what you are going to do. You are going to design a geometry of your road. Okay. And by definition, you can see a highway has many visible dimensions, both in horizontal plane and in vertical plane. So we are going to design that dimensions, which is known as a geometric design. Okay. What is our objective is to provide obviously optimum efficiency in the traffic operation. Why we have to design this? We can put any type of road, right? So we are going to design so that our objective is to, we have to provide an optimum efficiency in the traffic operation, and the very important thing is we have to provide the maximum safety at reasonable cost. These are the three different reasons. Okay. So efficiency, safety at reasonable cost. This will be your objective while designing a road. Okay. So consider three answers you are having: 90 meter, 100 meter, and 200 meter. So although the cheaper will be the 90 meter, that safety concern and efficiency concern should come. So I hope you understood. Okay. This will be our objective, satisfying optimum efficiency. We cannot provide 100% very good efficiency, but optimum efficiency with maximum safety what is available and reasonable cost. This will be our objective. As I told you earlier, we are going to cover so many things like design speed, horizontal curves and vertical curves, gradient and side distance. As I told you, we are going to see anyhow chapter by chapter this geometric design. Don't worry, everything comes under geometric design, you can see. Okay. So this will be your definition of geometric design. And remember, what are the factors going to affect the geometric design? First one is behavior of your road user. Okay. So we are going to see in detail in next slides. Anyhow, this vehicle characteristics and safety requirements, environmental considerations, economy. This is generally you should know, right? By the safety concern, obviously this will be taken care already inside the formulas. So we are not going to modify any type of formulas or define some theory for safety. theory for the environmental conditions, or theory for economy. Okay, so these are the factors where I hope you understood by the name itself, so we are not going to see in detail. Obviously, for safety concern will affect the geometry. Environmental considerations, something like if it is a rainy places, if it is a desert places, all those things will affect how the road will look like, correct? If it is a hilly area where the rain will be very high, so where the misty areas, something like that. So the environmental considerations obviously will going to affect your geometry. And also the economy, like same 2-lane road for 1 kilometer, if somebody is giving you 1 lakh or somebody giving you 10 lakh, anything, the road can be possible in any amount, but which that mainly concern about economy. Okay, correct. So how much they give you, if for construction, maintenance and operation, will change the way the geometry will look like. So geometry is heavily affected by the economy what they are providing you to construct a road. So these three is general consideration, obviously you should know by the term itself. Remaining thing I am going to explain in few minutes, how the road user characteristics is going to affect, what are the different types of functional classification, because types of road, if it is a national highway, the road will be different, if it is state highway, something will be different. So the functional classification also going to affect the traffic volume. This we will see in the traffic engineering chapter. Okay, and the design speed. So in coming slides we are going to see how these things going to affect our geometry design. Okay, anyhow you can pause the video and then note these factors. This they can ask you what are the different factors controlling geometry design. Is a general common question, at least you should be able to answer 5-6 points. Okay, so we'll start one by one. You see the road user characteristics. Okay, obviously the person who drive, consider there is a bike, or let's consider a car is more standard, so consider there is a car. Okay, so the guy who is driving the car, if based on his age, okay, age, if he is age 20, how he will drive, age 30, how he will drive, age 60, how he will drive, obviously everything going to be different. And if it is based on gender, if it is a male or female, obviously it is going to be different. Also whether he is under fatigue. Okay, he's I hope you understood the fatigue meaning, right? He is disturbed with some or he is restless, or whether he consumed alcohol, his habits, his skills, and also his safety characteristics like his vision problems and hearing problems, everything going to change the geometry required for the each person. I hope you understood. Each factor for each type of people need different types of geometry. So these are the total different factors going to affect because of the road user. Okay, so next thing you should know is, based on all these characteristics, IRC has defined a theory for the reaction time. So what is the reaction time is, obviously when a driver's response time to a particular traffic situation. Okay, so how much time I take to respond to a particular traffic situation, that is measured in terms of PIEV. Okay, so PIEV is nothing but perception, intellection, emotion and volition. So I wish to tell you a story. So consider I am driving in the same car. Okay, so I am going to hit some object, or let's keep something or another small bike or a small guy. So consider you are driving in this way, not in this way. So you are going to hit this, and consider you are a driver. Okay, don't expect you will be sitting outside, something like this. So consider you are going to hit an object. So I am seeing the object. Okay, so remember I am under the topic of reaction time. So how much time I will take to react to this situation? So that is the topic we are discussing. The step 1, what I will do, I will see the object. Okay, I have seen it, that is the perception. Okay, intellection means I am going to collect the previous memories of my similar type of incident. Consider I am a 20-year-old guy, I would have, if some similar situation have occurred in my past, so I will remember that particular situation, whether the already some similar object, and I consider at the age of 15 I got a very heavy accident and I recovered after 1 year. Okay, so I will correct that incident now. So when I am seeing the object, I will recollect the information of my past incidents. Consider he doesn't have any accident, or some other friend of his has an accident and he is remembering his friend's experience. So intellection means collecting the past information. when the similar things happened in the past, is mine or somebody else, I am bringing that information is how much time my brain will take for collecting, bringing that information is intellectual. I will bring out the same emotion. Like if you remove, if you see, if the object is so small in the past information, consider I have ran over it. Okay, consider like a dog, I just ran over it, I don't care. So I will bring the similar emotion what happened in the past. So or consider, as I told you, I got a very heavy accident in at the age of 15. So bringing that information to the current scenario, like okay, today, what I will think when I'm driving. Okay, I remember 5 years ago, I was stopped by a similar object. I hit him very bad, that object, and I got injury for 1 year. So I will bring the emotion of fear now. Okay, I will be under heavy fear. So I will bring the similar emotion what I faced 5 years ago. Okay, so how much time I'm taking for that, bringing that emotion, and I will be under that emotion. And volition, the final step is PAEV, volition. So I will take a decision now. So having that emotion, bringing that emotion, I can have a few, I can have fear, I can able to run over the object, or I will decide to stop my object, or I will take some decision based on the emotion. Correct. So the how much time you take to decide something, that is that volition. So this is the story. You can replay the video and listen. PAEV is a, I am seeing the object, I am bringing my past incidents, I will bring my emotions to that incident, and then I will decide something what to do. Okay, so this is the PAEV. This is the total reaction time of any type of driver, whether he is under alcohol consumption, habits, anything. So based on different users, it can vary from, if he is a very good guy and he is a very good concentration of the road, maybe he will react in just 0.5 seconds, or maximum it will take 3 to 4 seconds also for the complex situation. Okay, so the total reaction time varies from 0.5 seconds to 4 seconds, but IRC, Indian Road Congress, has suggested to take 2 seconds for overtaking side distance. We will see what is this overtaking side distance in 4 or 5 sessions later. This, and 2.5 seconds for the stopping side distance. So this is the IRC is suggesting take 2.5 seconds for the calculation of to stop your vehicle. To overtake your vehicle, at least a driver will take 2 seconds. Okay, so this is how, see, if based on this reaction time is changing, you will see in the chapter of side distance how that will vary the total length of the road itself. So this is how the road user characteristic is affecting your geometric design. Okay, so coming to the next vehicular characteristics. Okay, so first you should know there is something called design vehicle. Usually in India it was ambassador when they were doing that second and third road development plans. So the design vehicle is the one whose dimension and weight are adapted for determining the elements of highway design. So when they are designing a road, okay, so they will not design the road separately for a lorry, okay, like 8-wheeled vehicles, or separately for a car, separately for bikes. So they need a single standard vehicle, that is a design vehicle. Using that vehicle, they will devise everything. Okay, so based on the vehicle's dimension and weight, they will weight will come for a thickness of the pavement design. Okay, so you don't confuse yourself. And dimension will decide the vehicle's design, vehicle's dimension will decide the everything of the road. If you see the next, first I will finish this one. The width of the vehicle will decide the pavement width. I hope if you remember, width of the vehicle, consider this is the road. So how much is the width of the vehicle will decide the total road width. And length of the vehicle, we will see how. Okay, in few slides you will know how. The length of the vehicle will decide the turning path. There is something called turning path. So when you are having a horizontal curve in the road, the same vehicle, when it is trying to turn itself, so the turning path radius and how much setback distance required, everything depends on this length of the vehicle. So the length of the vehicle will affect the turning path. Height of the vehicle will affect the vertical clearance. So if you see the vertical clearance means there is a bridge going on, and there is a under the bridge road, there is another road here. So the clearance something like this. If you see, there is a bridge here and there is road undergoing below. So the clearance height, how much should be the height of the bridge from the ground level, is decided based on the height of the vehicle. Okay. Also the weight and as I told you, weight of the vehicle is for the design of pavements. Design of pavements means designing the thickness of the pavement. I hope you know the road will be something like this, right? So the thickness of the road will be designed based on your weight of the vehicle. You see how the vehicle characteristics is affecting the geometry design, correct? So width will affect the pavement width, length as I discussed, length will affect the turning path, height will affect the vertical clearance, weight will even affect your structural design of the pavements. So coming back, if you see, IRC has given some suggestions. For the maximum width of the vehicle cannot be more than 2.5 meter. Maximum length of the vehicle for two axles cannot be more than 9.5 meter. Axles, I hope you know something. This is one axle. Okay. So maximum length of the vehicle, two or more axles, it is maximum you can have 11.25 meter. Maximum height of the vehicle, it cannot cross 3.8 meter. Maximum height of the 3.8 meter. You should memorize these numbers. Okay, this can be asked in any objective type of even questions. Maximum height of the double decker bus cannot cross 4.75 meter. So I have given little more detail here. You can pause the video and note down, but all the meanings are little still same. Okay, so this is how the vehicle characteristics is going to change your geometry. Okay, next we have discussed something related to this functional classification of the roads in the I think Bombay plan or first Nagpur plan. Anyhow, the non-urban roads are divided into this type of classification. So they're dividing expressways, the geometry will be totally different. National highways, the geometry will be totally different. State highways, major district roads, other district roads, and village roads. And similarly, urban street roads. Okay, you mean in urban areas? They divided into further small 4 types of roads. Arterial streets, they are considering something like a heart as arterials, right? Something like that. Arterial streets, subarterial streets, and then collector streets. Collector streets means don't think it is a district collector, it is like a just collecting the traffic and distributing. Okay, it's like a that collector, not like a district collector. Okay, and then the local streets. So why they have defined this classification is for each road geometry we can have some changes, modification. Okay, what are the requirements for national highway? People who are traveling in national highway, we cannot no need to give the same priority to the village roads, obviously, right? So based on this also the geometry will change. Geometry design will change based on this type of classifications also. Okay, how the road has been classified, based on that also the geometry will change. Okay, so the next, so anywhere if I'm going quick, you can pause the video and note down the points if for whatever important points if you feel. Okay, so the next factor which is going to affect is the topography. I hope you know the topography. If it is a plain area, you can read those points. That's what I'm discussing here. If it is a plain area, the cross slope, plain means it's like a plain road, not like it doesn't have any rolling or mountainous area. It's like a 0 to 10% of the cross slope will be there. If you see 10% and if you see the cross slope, I'm telling you something like this. 10% means approximately what? 0.1, correct? So if you can write 0.1 as 1 by 10, right? So tan theta equal to 1 by 10. So opposite side is 1, this side is 10, opposite by adjacent is 10. Okay, so for every 10 meter 1 meter rise. That's what the plain area means. So the variation of the topography, I hope you understood the topography, right? Before you put in the road, where the variation of the topography will be less than for every 10 meter 1 meter rise. Okay, the variation will be something like this, less than 1 meter rise. That will be the plain roads. Rolling roads will be up to 25 meter. Okay, 25% of slope. You can even find the theta here, and then you can fill the theta values here, so that it is easy for you to memorize. You just find the tan inverse of this value. Tan inverse of 1 by 10 will give you the theta for this value, something here. And similarly you can find the tan inverse of 25% slope, tan inverse of 60% slope. Okay, so based on this, I think approximately you can calculate yourself. If the slope is greater than 30 degree, they will consider the slope as a steep. If the slope is greater than 30 degree, it is very for heavy vehicles and all, it's very dangerous. I hope you would have seen the landslide or slipping of the vehicles. So if the slope is more than 30 degree, then it is very difficult. So those things will be considered as steep terrains. There are so we have 4 type of terrains. Each terrain, plain roads is common. If the variation is less than, for every 10 meter 1 meter, or if it is less than, I think it's approximately 5 degree. I didn't remember, sorry, I don't have calculator now. You can even estimate yourself based on the tan inverse of this value. So this should be approximately in the nearby 5 degree to 6 degree. So if the variation is less than 5 degree, it is plain. If the variation is similarly 5 degree to, I think approximately around 15 to 20 degree, will be rolling. 20 to 30 degree will be mountainous. Greater than 30 degree will be approximately, it will be considered as steep. Okay, so this theta I am giving you for your understanding. So if the road variation or the topography variation is less than 5 degree, approximately it is considered as a plain topography. Okay, in that range I am giving you. So there are 4 terrains. Each terrain is going to modify. If you are putting a road in plain, national highway in plain, it will be different. National highway in the steep topography, it will be totally different. Okay, so this also will, topography also will alter heavily your geometric design. Clear? Okay, so the final factor, as we discussed in the factors, is very important, design speed. So every road will have a certain design speed. If you are having a national highway, and this is exactly the basic parameter. If you see, I told you we are going to see side distance, and I told you we are going to see some super elevation, we are going to see some transition curves, we are going to see some summit curve and valley curves. You will see no formula will not have any, you will not find any formula without V. That is a design speed. Okay, all the terms, starting from side distance to the end valley curve, everywhere you will see the V will be there in their formula. V is nothing but the design speed of the road. So it is the basic parameter. If this is changing, all the geometry will change. Okay, so this will be our final factor which is going to alter your geometric design. You can see for national highways and state highways, as I told you, you see I have defined the 4 topographies, just what we have discussed: in plain terrain, in rolling terrain, in mountainous terrain, and steep terrain. Okay, and this is ruling design speed. Ruling design speed is what is required, and minimum is at least we should provide this much. Okay, so for national highway and state highway, in plain cases, that is in a plain cases, you should be designing for 100 km/h, and in steep terrain case, you see at least minimum you should have you should design a road for 30 km/h. Similarly, you can see for you can pause the video and note down MDR, ODR roads and village roads, what are the design speeds, and no need to memorize anything. In my experience, mostly they will give you, or nobody is going to ask you anything from anywhere other than national highway problem. So mostly all the time, most of the problems will be coming in terms of national highways. Okay, very rarely they will go for a state highway. So the design speed, something related to national highway, will be enough. Okay, so you can pause the video and note everything, the design speed. And also, as we discussed a little earlier, there are other roads also, right? Road classification as arterial roads. So the design speed you should consider is 80, subarterial 60, collective street is 50, local street is 30 km/h. This will be the design speed for designing this non-urban road areas. Okay, so this is how design speed is defined by IRC. You can copy these values. We will see how it is being able to modify the geometry in coming lectures. Okay, so I hope I made you clear the design speed, how it will alter, topography, how it is going to alter, and what we have discussed. Other than topography, we have seen road user characteristics, vehicular characteristics, etc. Okay, so we will see in next session what are the different various elements. Still we are under introduction, not we didn't complete it as whole. So we will see remaining various elements of the geometry. Now we are going to see the cross-sectional photos, and with photos and images I will explain what are the different various elements in the geometry design. Okay, so we'll see you in the next session. Thank you.